Okay, welcome everyone to Container Registry Deep Dive. We're going to look at just the code path that you'll take during a push and a pull. So we'll likely not cover everything, but we will cover some things. All right. So the biggest thing is if you have any questions, just ask. If I'm going too fast, let me know. So I'm going to share my screen and we're just going to look at the push-pull diagram. Okay, so this is the pull. We're going to do this first because it's way simpler. And we're gonna just skip over some parts of this because they're not as interesting. They're more complicated in some ways, and it's just easier to ignore it. So we're not going to do any of the auth. We're not going to do like the check v2 because it's not interesting. We're not going to do the auth because the auth is its own subject. So when you pull a container image, you want to pull down. There's really two parts of a regular image. So a regular container image, there's the manifest, and then there's layers, and that's kind of the deal. That's kind of the dichotomy. If it's not a manifest, it's a layer or blob. So when you pull, you get a manifest by its reference, which is either going to be the tag, which is almost exclusively going to be, or the reference. The other reference is the digest, which is the hash sum of its content. And then once you get that, if that checks out, everything's okay. You're also going to get the image configuration, which is a special blob. So you always do that. And then for each layer, you'll get those. And those are also the same path. They're not treated differently as far as storage goes. They are, but the configuration is special. And we'll get into that maybe a little bit, but typically the blobs you'll treat as opaque. You don't really know what's in them in the code. Like they're just a solid chunk of bytes. The manifest, we do inspect that quite a bit just because there's numerous things that make us need to know what the manifest is about. We'll see that more in the pull, or the push rather, just because we need to validate that everything's okay and we need to read the manifest to do that. Yeah, so let's go.
Quick question here.
Oh, sure.
Yeah, so in the first request, it's just like simple get to the v2. Do we specify there that we're gonna do a pull so that we get a reference back?
Nope. I'm glad you asked because that's a point that is normal to me, but it's something that it does come up, and that all these requests are not correlated. That's the client decides to put these together correctly for the most part. And for pulls, somebody could just pull a blob down and leave us alone for the rest of the day, right? So clients generally coordinate the right way to do this. And this is specifically a Docker client. It's, for pull, there's only so much you can do, but for a push, it's conceivable you could do it slightly different. But yeah, so the client is basically responsible for coordinating how to work the API properly, if that makes sense. In the same way that it doesn't say, hey, I'm gonna do this pull, or I'm gonna do this push, and like look for these requests coming. We don't really know, especially for a push. A client could just push blobs. Not thinking about lifecycle management, but a client could push one blob every day for a month and then push a manifest 6 months after that, and like we wouldn't know the difference.
Yeah, got it. So basically the container registry doesn't care about like an image in general. It just knows about blobs and this manifest kind of
Yeah,
thing.
and that's great. And I'm glad you mentioned that too, because like you'll find in the code, nothing is an image. They're just plain not mentioned. There's manifests, there's blobs, there's manifests, and then there's blobs, and that's kind of it. There's also tags, but they're tags for manifests. So yeah, that's one of the things that is, it takes a bit to get used to, is the registry just does not have this consolidated view of an image. Everything's very broken apart. And that makes sense in a way that we don't really do anything with the image as itself, like, because we would have to make it an image, you'd really have to reconstruct it from the layers. And the registry doesn't have any sort of container runtime. It can't do that. You know, the registry really doesn't know if an image even works, right? It doesn't even know if it's like makes sense when you put it all together. It doesn't know how to build it. It doesn't understand what's there at all, which is, you know, upsides and downsides. It does simplify things a bit, but it does also mean, you know, certain things are harder to do or just aren't available. But yeah, and that'll become clear as you work. It's hard to, like, you know, you'll get a sense of that as we go through. But
I suppose one of the problems is you can end up having a lot of garbage in there, like a lot of blobs that are not even related to each other, or, you know, if whatever client decides to push.
Yeah, sure, of course. And as you read the garbage collector, the online garbage collection, like a specification that we have, that's part of it. That's part of the reason why it is because you can just push a blob up and walk away and never make another request. So there's a lot of things that we have to accommodate that's very possible. And, you know, clients don't communicate intent. They just say, I'm putting a blob, I'm getting a blob, I'm heading this manifest. So we really don't know what a client's doing, request for request, you know, request for request. Yeah, so let's look at the, we're gonna look at the manifest get, and then we're gonna look at the blob get. So those are pretty simple. And let me bring up my thing. Yeah, so you should see nothing. So we're gonna do handlers manifest. Yeah, so we're just gonna go right to the handler, the app. The part where it routes to this is pretty interesting. So one of the things is, like, the head and the get method is, I think, always the same. It works out. It works out more or less okay. So now everything, this method is repository scope. So everything is about a particular repository. So you'll see everything's kind of scoped under that, in a way that, like, you know, when we get a blob, that blob isn't just in the registry. That blob is associated and known to that particular repository. So let's see. So we have this thing is a little constructor that's fairly new. We have the split in the registry that, you know, some requests are done by the database and some requests are done by the file system. And as we roll out to production to do that, the same instance of the app is going to take one request, and maybe it goes to the database, take another request, and maybe it goes to the file system. So there's really two registries overlaid on top of each other, and that's going to make this dive a little more annoying. So I think I'm going to focus on the file system one, because that's what you're working on right now, Jaime, and it's easier in some ways. In some ways, it's more complicated. So if we go down here, so this is just, we get we figure out which one we're supposed to have, right? And we can just not ignore it in the body of the handler here. So it's either going to be like a tag, as I said, or it's going to be a digest. So that's these lines here. By tag, by digest. I would say 99.99% of the time getting it by tag. I think some clients will also try to like head it by digest to make sure everything's cool, but tag is what people usually do, or what clients usually do rather. So yeah, let's gloss over the fact that we got a manifest, a digest, and an error. So the digest is what you'd expect. It's the content addressable digest. It's the digest of the content. So that's how this is stored on the file system. So it's pretty important. And we also have the manifest. And in this case, it is a distribution manifest type. So I'll go over that real quick. And there's not too much with this type. So we can return the references, which are everything that the manifest references. So if you have a manifest list, this is a list of manifests, usually. And if you have a regular manifest, you're going to have the config first, and then all the layers you're going to get from these references. And the payload, it will return the media type. So the media type for OCI manifest, media type for Schema 2 manifest, the payload, and an error. So the payload is the bytes that are actually like the manifest JSON, as you'd see in like an example of like, you know, here's what the manifest looks all built out. So there's not a lot really you can do with that. So what you're going to see a lot in the code is there's a split. This is a fairly new interface, which counts for both OCI manifests and Schema 2 manifests. So it's everything the manifest is, plus you can get the version, which is just the Schema version, which is just an integer, and then the oh my gosh. So it's the Schema version, and it's the media type with the manifest. So it's not too complicated. It's just, you know, what kind of thing is this? And in particular, this one lets you get the config and the layer separately rather than all at once with the references. And it also lets you know the total size of, you know, the manifest, like the manifest content itself, the layer, and config blobs. So that comes up for the database. It doesn't come up for the file system. So you'll see a mix between this interface, and type switches, because sometimes the concrete type is important. And in a lot of the older code, the type switch was just how you would differentiate between Schema 1, Schema 2. Schema 1 we pretty much don't use anymore. There's still some in the code, but the API can't handle it anymore, which is great. It made the code a lot better. So how you differentiate between the different manifest types used to be a lot more type switching, and we still have some of that, but it's reduced a little bit. So excuse me while I flip. Okay, so let's just say we got it by tag. We have the manifest, we have the digest. Let's pretend there's no error, because let's pretend there's no error. So now what we need to do is we need to determine the type of the manifest. And this is older code, so we do have the Schema 1 here. We still need to check this out, because there's nothing, you know, older, you could hook a new registry client to older object storage or older file system and have encounter manifest Schema 1. So we want to be able to say, this is a Schema 1 manifest. We don't do that anymore, right? We don't want to just panic if we get these kind of things, or an error that's just like, I've never heard of this before, because that's not really true, you know. So we also have schema 2 and manifest list. And if it's a manifest list, it could be an OCI image index. And if it's like a regular manifest, it could be schema 2 or it could be an OCI manifest. So that's just a bunch of checking there. And then this here is like, hey, if it's manifest schema 1, we blanket, we don't support it, like end of discussion. And if we do schema, if it's a schema, OCI schema, we check if we support it. If it's and this is like this is the client. We won't go too far into this, but the client needs to communicate like, I know how to handle an OCI manifest. I know how to handle an OCI image index. It used to also need to say, and it will send the information up still in the same way, but it used to also need to say, hey, I support schema 2 manifests. But we dropped support for schema 1, and now we just assume that any client is going to support schema 2 manifests by default. And yeah, so yeah, so if we have a schema 2, if we have a manifest list, a Docker style manifest list, so that's not an OCI image index. If they don't support that, we're gonna try, and they're getting it by tag, since if it's by digest, we can't, we have to return something that matches the digest, period. But if they're getting it by tag, they don't support the manifest list, we're going to give them if we can find it, we're going to give them the AMD 64 Linux manifest from that, and we're just going to give it to them, and it's just a fallback for clients that are not supporting manifest lists, which are technically still experimental, although they're pretty widely used at this point. So you'll see things where I think we saw some issues where it's like, hey, manifest lists aren't displaying properly, and it's like, well, that's because the client isn't saying, I know about manifest lists. So you're just going to get the one image as this is probably okay, it's probably Linux AMD 64. Yeah, so, and then we get the payload. So we get the media type, we get the payload, we set the content type to the media type, content length to the length of the payload. We, set all the headers here, set the E tag, write the payload to the body, and we do some little logging here because we keep a lot of metrics this way. We keep some metrics this way. So yeah, that's the Git. It's relatively straightforward. Where it gets tricky is what's the support looking like? Do we need to rewrite this? That's where the extra logic is, besides just getting it from whatever storage we're using. So if all that's kind of clear or makes sense, I'd like to move into like actually getting the manifest from storage, if that's all right.
Yeah, it's straightforward. I'm sure missing, details and maybe a bit of the background, but it's so far so good.
Likely. So let's just do get by tag. With these, so that's the database. We're just ignoring the database because we just are, because it's easier if we do it. So what have we got? So the file system manifest getter, we have the tag store, which is here. We have the manifest service, and then we have the request. So that's all the request information. And when you see these like manifest service, so it's repository manifest service, it's repository tags. So these are by default, they're scoped to only the repository, only the part of the request that is not the reference. It's just like, this is where you'd say Alpine. or this is where you'd say Nginx, our GitLab org, GitLab or container registry, right? So that scopes the tag to I'm only thinking about tags in this repository. I'm only thinking about manifests that this repository knows about. So let's go through, and so what we'll do to get the tag is we get the tag from the tag service. Great. So we pass it the name, and what this does is it finds the reference for the tag. So it gets the description, the descriptor for the manifest. And what is the descriptor? Well, a descriptor is it describes stuff, describes things that are content address stores. This is a manifest can have a descriptor. A configuration has a descriptor. Layers have descriptors. These are just the most. These are very general. A manifest can have descriptors. Can they? Doesn't matter. No, we'll get to it later. So the descriptors are just very general. So media type, size, the digest, very rarely URLs, sometimes annotations. Platforms, if they are manifest list manifest, say like, hey, this is for Linux, this is for Linux AMD 64, right? That's the platform. So the descriptor is a really basic thing that says like, this is the digest, this is the size, this is the media type. It's very simple. So we get the descriptor, and then what we see first is like, hey, does this descriptor, does the string of the digest, does it match the e tag in the request? So if a client says, oh, give me the latest, right? And they already have, the manifest that's the latest on their system, but maybe they pull it as like v1.1.0. This checks and says like, oh, well, hey, you've actually got that. It's this. And we can just say, hey, the e tag matches, like, you don't need to do anything. You've got it. So very nice thing here. And so then if e tag doesn't matches, we really don't have it, then we're going to get by digest, which is, e tag match, again, because sometimes if you get by digest and you send the same digest, you need to do an e tag match still. And this is very simple. We just go to the manifest store get. So there's a lot of, these are very abstract. These are mostly just to smush together the database and the file system metadata. Before, this is all in the handler method, like the get the handler callback, and it's just not, once you overlay the metadata for the database and the file system, it helps to just have something that splits these out. So we're going to dive into the actual source. So let's look at tag store get. Actually, let's back up even more. Like, how do we get this? How do we get the tag store? So we get this from repository tags. So registry storage, tags. So we're just going to instantiate a tag store. It has the repository, and it has like the Blob Store. So not a whole lot there. It's easier to see once you're in the tag store. So the actual tag store, we'll jump to registry storage tag store, and let's look at get here. So all the file system data metadata, it's all just, there's paths, right? If you think of let's let's go to path. So you'll see the layout like this, so hey, you've got the repositories, manifest, tags, layers, all this kind of stuff. There's a link. So we're going to refer back to this when we're talking about the tag, the file system metadata, because it all goes to this tag spec that the drivers actually get from the back end. So I believe it's this. So this will be, the root v2 repositories, let's say Nginx, manifest tags, the name of the tag, current link, and that file will contain the digest of the manifest. So let's look at the tag store again. So path for manifest tag current path spec. So that's what you get here, is you get that sort of template filled out. So, and then we read link. So that's just, we just get that digest out, more or less, right? And hey, if that path doesn't exist, hey, that's unknown tag. And then we return the descriptor, just like you saw. It's pretty simple. We're just opening up the tag and seeing like, oh, it's actually this, it points to this digest. Anything unusual so far?
No, I think it makes sense.
Yeah. So
when I start playing with it, that's
yeah, I mean, it's always this will sort of put things, hopefully it puts like hooks in your mind to be like, oh, there's something there.
It is, because I was looking at the content in my local file system. I could see that directory structure. I could see the the JSON blobs in the manifest, and so it kind of makes sense. And now I get why we have a current and an index and some of the things.
Yeah. So let's look at the manifest store. So we're gonna get it, and we get it by the digest. Always on the file system, to get a manifest, you need the digest. You can't, there's no direct lookup by tag. So if you have a tag, there's always 2 requests to the storage backend, because first you need to get the digest from the tag, and then, and only then, can you actually have something that the manifest store knows about. So let's say, so the first thing we do is we get it by the Blob Store. So this thing, the Blob Store, this is not any Blob Store. This is, there's 2 Blob Stores. So that is, I don't know if you see this at the bottom, that is a linked Blob Store, and there's also just a Blob Store, but they just call them Blob Store a lot in the code when they're instantiated and embedded into another struct. So how on earth do you get the, how on earth does this work? So we got to get a linked Blob Store first. We got to take a detour. So yeah. There's another HTTP request, because we've got a stat. We're actually going to stat the repository's ability to access this, and I'm gonna gloss over this because in the interest of time. But so we actually have to make a stat request to say like, oh, this is actually accessible by the repository. And the stats a little bit weird, because like, what stats? It's the blob access controller, which that gets in, that starts to get that's part of like the caching for blob descriptors, which we have turned off in production now. So let's go down to the stat method that it'd fall back on, because it's always going to do this. So it's going to look at the blob link path and read the link. So there's like 2 layers of indirection, right? So you get the tag and you look up and say like, oh, it's this digest. And then you use that digest and you do a similar thing to check and make sure that that digest is accessible and all that kind of stuff. So we'll look at the link path. And that's gotten from the link path function. So the link blobs, oh my gosh, I don't know why I just moved away, but the link blob store, I'm gonna cough, excuse me, if I can. So the link blob store has 2 sort of it'll pull double duty. Anything that's like any layer of indirection, it sort of handles. Like it handles like, given this digest, can the repository access it? And it works for different kinds of like a manifest or a blob. They're stored in different places, but the link blob store just takes that link function and says like, and like it just figures out how to get it that way. So it's the same code, but the thing that changes is like the path it gets for a digest, and we'll look at that now. It's the manifest revision link path for manifest revision link path. Yeah, so that's here. Yeah. So this is the repository scope manifest. So it's v2, repositories, name of the repository, manifest revision, the algorithm. So 256, SHA-256 almost exclusively, then the digest, and then a file called link, and that link contains the digest. And basically this is here for if a digest is SHA'd with a different SHA hash, but I have not seen that ever, but it's possible. That's why the algorithm is variable, but that's one of the reasons, the reason that we see in real life is that, hey, can this repository doesn't know about this manifest? So that's what this does. We're just okay, so Blob Store get. So we do next, let's check that way. And then we actually get the content from the other blob, the Blob Store's Blob Store, which is this one is, it deals with the other side of the registry. So if I may go back to the past thing again, and sorry, I'm jumping around. This is just following the flow and it does jump around like this. So there's basically 2 sides of the registry, like file system storage. So there is this is highlighted. This is the repository scoped metadata, essentially. So nothing is really stored here long term. The only, with the exceptions of uploads, that'll actually have content, but only for a bit, only while it's being uploaded. And this is the other half of the registry. This is where all the content lives, and it is completely deduplicated. It is instance wide. It has no metadata. It is just content addressable storage. So that's where the non-linked blob store interacts with this, and it's quite a bit simpler. Store. So when we do get, we get the path, and then we just call the driver directly to get the content out of the path. It is quite a bit simpler, and this mostly figures out the path and passes it off to the driver. It just coordinates the driver, and so the raw storage driver, which is, so we're going to get content from the, get content. Yeah, it just means, it just like uses the driver, basically. So it's not that complex. Like the Blob Store is just going to reach into the actual content storage and get stuff out of it. So now that we've got the content, that's great. Unless we don't, so that's just like, hey, we couldn't find it. And that's either that it's not in the storage backend or the link isn't there in that repository. What we do encounter on production, something that's really interesting, is that we will get zero length content that's, it shouldn't be zero length. There's a canonical zero length blob digest, but manifests have to reference something. They have to have some kind of content to be valid at all. So for some reason, we do encounter this occasionally, and we would just return the special error here. It says, hey, like this is an empty manifest, and it's going to come up when we do importing into the metadata database. Once we start doing that in production, like we need to watch out for this and make sure, like, hey, like there's nothing we can do. Like, don't stop, don't stop on this error. It's just something that we can't really remediate. But once you have the content, and you really, really have the content, you unmarshal it to get the manifest versioned. And so this will just get that the schema version and the media type. And so if the schema version is 1, we do the schema 1 handler, which we can simplify this code now. We just haven't. This is just going to go to something that says like, you can't get this. It's well, actually, I think we do unmarshal it maybe. Anyway, it's not this interesting. We don't do this in the API anymore. But if it's schema 2, we do this type switch, basically, but except with the media type manifest. So like, hey, if it's the schema 2 manifest like here, unmarshal it like it's a schema 2 manifest. Same for OCI, all this kind of stuff. Like figure out what type it is, unmarshal it for that type. And that's it, so there's a little bit of a validation step for the get, but only enough for access, like make sure the repository is scoped right, and only enough to turn it into a manifest that's just formed correctly. So yeah, that's manifest put, or manifest get rather. That's manifest get. And that's the simplest, and it took an hour. So what we can do is look at the blob get handler. I think we have time to do that. Do you have any questions?
Not now.
Okay, yeah, it's fine. There's a lot of this is very download kung fu into your brain from the Matrix, I bet. So it's
very slowly.
Yeah. So this is a little easier because the linked blob store, the blob store, it's all involved. We've done a lot of these steps already with interacting with the file system metadata, how that's laid out and how access is controlled that way, and the actual getting the content off the common blob store. So this is going to be a lot quicker. And you see, we don't have the same sort of like everything's in the handler. It's a lot simpler. So hey, if it's the database, like whatever. We're just checking for, does this exist in the repository? So For the database, does the blob link exist? Because we've already talked about it. It's right there. It's hard not to say something. Which is the stat. Hey, we've statted it. Great. If it's stat correctly, we have the descriptor, and then we serve the blob. And so there's a couple of things that can happen here, and that is we directly take the connection and we serve the blob. We take multiple requests to download all of it, and that's what you get with like a file system driver, because it just lives on the registry, quote unquote. What often happens with object stores is you'll actually we'll just pass along a link that says, here's a URL where you can get the blob that you want. Don't come back. More or less. So there's not a lot here that we haven't discussed with the storage. So let's look at getting the blobs object. And so, because the blobs they're repository blobs. So let's look at and go through that sort of situation with just the blobs. So the repository blobs, we'll go back to storage, registry, go. And this is where all the storage stuff is like brought together and coordinated. So blobs, so repository blobs. So it's a linked blob store. As you can see down here. And this just like, it's just the configuration for that, basically. And we do have what's interesting here. So the blob link path is what's interesting. And if we go to the paths, again, blob layer link path spec. So that's just, there's a layers folder. It has the algorithm. And this is just the layers that the repository can access. It's a bit of a weird thing. It's easy to forget it's there. And there's definitely like the offline garbage collector doesn't clean these up, for one. So that they're easy to forget about in a way. But there is an API endpoint that will delete this link. So you can have that link be severed if you don't want that content. And it's a bit of a dirty thing to do, because now you can't pull those manifests if your client decides that you need that layer. When you got to pull the manifest that references that layer, it's going to error out. So it's a bit of an odd thing, but apparently it's for security reasons to, hey, like this layer shouldn't be up on the registry. It shouldn't be accessible by this repository. You can just get the layer and delete it. So it's a bit weird, but mostly it's for access check. And once the layer's there, it's usually not going to go away. And this will come up when we push blobs, because it gets into blob cross-repository blob mounting, which is great, and you'll love it. But we don't have time for that. So let's look back at all right. Storage, registry storage. Okay, so the blobs are just a linked blob store rather. And so what we did is we saw that we statted, which we just went through before. We're going to do the same thing. We're just going to have the storage driver interact with a different path, that layer link path that we talked about. And what we're going to do is serve blob, which is basically going down to the real blob store. Oops, blob store to get the serve blob store. How about there's a I know I can spell. Is it just serve blob? Oh, it's blob server. That's it. There's a blob server object. Okay, so this serves the blob, and there's a lot of stats for access. They're all over the file system metadata, and so things that you think are a single operation are quite a bit of chatter back and forth to the backend. So this is basically, hey, can we redirect this repository, because it's a repository scoped redirect turn on and off. So let's see. So we basically just asked the driver there's drivers have a URL for method, and yeah, we can just say look at the URL to download the blob. Easy. So sometimes, hey, we don't support this method. Like there's no URL for the file system driver, for example, or there's no URL for the in-memory driver, as you would imagine. So then we just make a new file reader, and we set up the headers so we can start serving this content. And yeah, I mean, that's just the whole process. Like once that's set up, then it's just it's mostly driver stuff at that point. It's not super interesting or not super unexpected. You can definitely look at that later when the actual driver, but it's just a file reader. Offsets, all that good stuff. Nothing surprising, really. So that's how you do it. Yeah, so that's pull, and that hits all the high points. It's
so this pull, like this blob, is gonna, the client will make as many requests as there are layers in the manifest. Is that correct?
No. Is
or only the ones, that they don't know about.
Right. So you're gonna make a request for the manifest. You're gonna make a request for the configuration blob, and you're gonna make a request for each layer. Yep. So that's if it didn't have anything. Clients, I don't know how smart they are, but I imagine when you get the manifest and you're like, oh, I need this blob with this digest, and it's like, well, I have that locally. I imagine the client is going to take the opportunity not to make the request. But as the registry, like, we don't care. We don't care why you're doing this. Like, there's nothing that would stop a client from doing this backwards, except that they wouldn't know what layers to get.
Just give me a random one. Yeah, okay. It's a bit abstract in a sense that the registry doesn't care. It's just like one blob at a time, and that's it.
Yeah, I mean, I think the registry tries to be, it tries to know as little as it can, which is great. It's a bit weird because it doesn't, somebody who's used Docker or someone who's like has this concept of what a container image is, it doesn't track to that at all. So like that's the thing that's sort of like you have to put your registry goggles on, and like there's no images, there's blobs, there's manifests, there's blobs, and there's manifests. The manifest references blobs, and then there's just blobs, which are blobs, and there's nothing you have to really think about too hard. There's just blobs. Who knows what they're for?
Yeah.
Yeah, so I think this is a natural place to cut it off. I think it would probably take another 2 hours to do the pull. One for the blob, I mean for the push, like 1 hour for the manifest, 1 hour for the blob, perhaps.
I can imagine there's a lot of validation happening in there.
Yeah, a little bit. But I think the thing with push is that if we look at it just briefly, like yeah, in some ways puts I mean, it's not too bad anymore, but there's a lot more checking up. The range of things that can happen is just more. You know, you'd think it would be the inverse of a pull, and in some ways it is, but since writing is just a more expensive operation, there's just, you know, things like cross repository blob mount, and there's validation, and then there's you know, if a manifest or a layer is on the registry, like the assumption is that for the most part that it's valid and correct. And so when you're putting, there's just more, like you said, there's more validation, there's more distrust of the content until we decide like, all right, we're gonna push this down to storage. So that's, I think, where it gets a bit more tricky, as well as when you do puts, there's a lot of gets requests to do the push. I think you know, because the clients will say like, hey, is this blob here already? Because if it is, we're done, right? So there's a lot of reads, like there's a lot of read type requests that goes with a push. So I think that's what causes it to be one of the things that causes it to be more complicated. And cross-repository blob mounting is complicated, and blobs don't go directly to storage. They go to an upload directory and then they go to storage. So there's just a little bit of a, you know, there's just more that happens. It's hard to say that. And if we you know, just I'll share the screen again. But so this is the pull request diagram, and this is the push request diagram. So just for and not to really dive in, but with this video, but more stuff happens.
Apart, there's a couple of loops in there.
A couple of loops, but not enough to make it that big.
Okay.
Yeah. So that's good. That's the very quick version of where things are. So I mean, I think the overview is for the file system metadata, paths.go. That's the layout of all the stuff. Like, and then there's really a link to Blob Store, which operates on the repository side of the registry. And then there's just Blob Store, which operates on the blob side of the registry. And everything else is just sort of figuring out where to send the link Blob Store, basically. So that's what the file system metadata, you know, the database is. In some ways it's simpler because databases are more standardized. You're just like, build up the object and say, you deal with it. put it in the table.
Yeah.
And it's kind of more atomic because we just make the database do all the complicated stuff.
Yep.
Yeah, but that's about the size of it. And pools are 92, 94 something percent of the traffic. I mean, 97 maybe. Tremendous amount of the traffic are just pools, more or less.
Mm-hmm.
So it's a very read heavy thing, and that's where we do most of the operations. We're just reading.
Yep.
You know, so that's the thing. I mean, I think everything's covered. Like with the file system metadata, those two blob stores are just tremendously do all of the things for the most part.
Yeah.
Yeah, so I think we're gonna stop the recording, and I hope all of the people following along at home have completed their worksheet they should have gotten under their chair and can send it etched onto the bow of a 40-foot yacht to my home address.